Hello everyone, my name is Emily Wade and I am part of the engineering checks. Unfortunately, Ashley can't be here for the recording of this video, but I'll go ahead and get started. So today we're going to prove pi through Monte Carlo, and we're also going to include our confidence interval. We have a video like this already on our channel, but it does not include the confidence interval, and we wanted to add that in for you. So up here we're kind of just initializing our starting points. B is our radius, and we are going to be going off of the unit circle today. And so right here we're selecting a random x and a random y, and we're going to do this for, I think we have it for 100,000 times. That's our number of simulations. And then we're initializing our I value, and then we're setting our counts red and count green to 0. The count red and count green are going to come in handy when we start going through and deciding whether the randomly generated x and y point is above or below the function of a circle. So that's kind of starting into this portion of our code right here, where we have a loop that says for I to n, which was 100,000, we're going to go through those randomly generated coordinates, and if the randomly generated coordinates are greater than the function of a circle, it's going to count them as green, and it's going to plot it above the arc on our graph of the function of a circle. And then if it's less than or equal to the function of the circle, then those points are going to be graphed in red, and those will be featured underneath the function in our graph. So I'll go ahead and run it so we can look at the graph. But our next kind of important thing is to look at is the proportion. So we're multiplying by 4 by the proportion once we get the total number of red, which is the number of points below the function of a circle, divided by the count total. You can see that's represented in our graph right here. So we're using multiplying it by 4 because the ratio of the area of a circle to the area of a square is p equals the area of a circle over the area of a square. And so for the unit circle, that kind of just boils down to mathematically pi over 4. And so we're isolating pi, so we're multiplying their proportion p times 4. Just down here, the code's just doing the graph on that I just showed you. And then down here we're calculating our confidence interval. This is a 95% confidence interval. So let's go ahead and check out what that gave us, our answers. So mu, that's our calculated value using Monte Carlo. That's our answer for this problem. So we got 3.1412. And as you can see, that does indeed fall within our 95% confidence interval, which proves that we have calculated pi correctly using Monte Carlo. Thank you for your time, and I hope that you enjoyed this video.